Hello students, today you will be taking notes on writing fractions as decimals. So fractions as decimals. Now there are going to be two types that we're going to talk about. They are going to be terminating and the second will be repeating. Now, terminating means exactly what it says. When you terminate something, it ends. When repeating, it's obviously going to do what? Repeats. Now, if it repeats, you're going to see some kind of pattern. You've got to be able to see that. If not, it may be a terminating. So let's start with one. Let's say we had 3/4. If I wanted to turn this fraction into a decimal, I'm going to put it into a house. Remember, which number always makes it in the house? The one on top. The one on the bottom is on the outside. It's my divisor. Now, if I'm turning a fraction into a decimal, I'm going to add the decimal, bring it up top, and start dividing. Will 4 go into 3? No, it doesn't. I can put a 0. I don't have to multiply that out because I know it's just going to be 0. I'm going to add a 0 to continue. Will 4 go into 30? Yes, it goes in there, what, 7 times? 7 times 4 is 28. Go ahead and subtract. That's going to be 2 left over. Now, it did not terminate, nor do I see a pattern. So I'm going to annex another 0, bring it down. Will 4 go into 20? Yes, 5 times, which is 20. And what do I notice about this decimal? It terminated because I got to a 0. Now, let's do one that's possibly a repeating. Let's do 1 over 3. So now what number goes in the house? 1. Even though it's the smallest, we put the 3 outside, carry our decimal. 3 does not go into 1, so I'm going to add a 0. Will 3 go into 10? Yes, it goes in there 3 times, which 3 times 3 is 9, with 1 left over. Annex a 0. 3 goes into 10. Well, I just said that. 3 times, which is 9. 1. And what do I notice? It's not ending, but I do notice that I keep dividing 3 into 10. So I'm going to stop on that one because I know it's going to be a repeating decimal. Now, what is actually repeating? The 3 is repeating. So this is going to be, it's not 33 repeating, it's a 3. And we're going to put a repeater bar over the number. So my answer to 1/3 is going to be 3/10 repeater. And that bar says repeater. Now, let's do one where it doesn't just have one number like that repeating. So let me do, let's say -11/6. Now, doesn't really matter that it's negative because I just know one negative means my answer is going to be negative. So now what number makes it into the house? The 11. Put the decimal, carry it. Remember, I'm just going to go ahead and put my negative up there because I know my answer is going to be negative. 6 does go into 11 one time, which is 6. Go ahead and subtract. 5 left over. No pattern. Did not terminate. Add a 0. 6 goes into 50 8 times, which is 48. Subtract. 2 left over. Still did not terminate. I still don't see a pattern. So I'm going to add another 0. 6 goes into 20 3 times, which is 18. Subtract, I'm going to get 2. Add another 0. 6 goes into 20 3 times again. I'm going to get 18 again. So I'm noticing this is not ending here. I'm noticing that this 3 is repeating. So what would be the answer to this problem? It would be -1 point, which is 1 n, 83 hundredths with the 3 repeating. Now I wouldn't put 33, just the 3 is repeating, and I wouldn't put the repeater bar over the 8 because the 8 didn't repeat as well. Only my 3 repeated. So that's the way this one would properly be done. Now, let's do one more that could possibly be terminating. 2/5. Now, 2 goes in the house. Put your decimal, carry it up. 5 does not go into 2, so we're going to try 20. 5 will go into 20 4 times, which is 20. Leaves me with a remainder of 0. That is a terminating decimal. 2/5 is actually equivalent to 4/10. So that is taking a fraction and turning it into a decimal. Now, can we reverse this process and turn a decimal into a fraction? Absolutely. Let's say I had 0.6. Well, if you read that in proper math terms, it actually tells you how much it is. So if I was to read that correctly, I could say 0 and, or I can just say 6/10. So when I say 6/10, that tells me it's over 10. The decimal in one place is going to be my tenths. So if I had 0.45, or if I said 0 and 45, if I read that in proper math terminology, that would be 45 hundredths, which would put it over the 100. So you notice 2 here, I'm going to have 2 zeros, just like 1 here, 1 there. What if I had 2? Let me see, let me back that up. I can't erase here, so. Okay, let's say 145 thousandths. That's how I would say it. So that must be 145 over 1,000. Now, I noticed 3 numbers here, 3 zeros there. Now, can these reduce? Absolutely. Remember, when we're dealing with fractions, reduce. Go back to where we found the greatest common factor and simplest form, where we used our upside down division, the ladder division, the cake, whatever you want to call it. We have 6/10. What are these both divisible by? Well, 2. 6 divided by 2 is 3. 10 divided by 2 is 5. So 6/10 actually reduces to 3/5. 45 and 100. What are these both divisible by? I know they both end with a 5 or a 0, so it has to be 5. 45 divided by 5 is 9. 100 divided by 5 is 20. These two have nothing else in common, so 45 hundredths actually reduces to 9/20. And the last one, 145 and 1,000. Once again, if I'm unsure, I'm going to start with the 5. So if I do the 5, I know the 1,000 automatically. If 100 was 20, this is going to be 200. Now, if I'm unsure here, I'm just going to divide that in. 5 will go into 14. What is that? 2 times. With 4 left over, 5 will go into 45 9 times. Well, 9 is a prime number, so that means I have to be done. So 145 thousandths reduces to 29 over 200. So we can take a fraction, turn it into a decimal. We can also take a decimal and turn it back, but just make sure we bring it down to its simplest form by using our ladder division or upside down division. All right, we'll see you next time.